Hi everyone. Well, congrats to everyone for all 34 people who are here today. So we have about 5% of the course, I guess. Um, Maybe a bit less. 4% have decided to turn up 8 minutes after iteration 2 is due, which is super exciting. So props to everyone. Um, I assume there's a small percentage of you that are interested in um, learning today, and I assume there's a handful of you that are suffering from Stockholm syndrome, and this is your life now. Um, but it's an interesting thing, iteration two, and how it was due because in previous terms we kind of did 3 weeks per iteration. In this term, we kind of made the decision that iteration two is kind of this formative iteration where everyone really has to sink their teeth in and get it, right? It's the first time that you really have to make things work as a group. It's the first time you really have to like see the application work as opposed to just like these few kind of little isolated functions and stuff. So that's why we've done this 4 weeks, and then iteration 3 is 2 weeks. So I'll be interested to see people's feedback at the end of the course, because, and I know I say you're like, wow, iteration 3 in 2 weeks, I can't believe that. That sounds crazy. But like, if we gave you all 5 weeks for this, most of you would be in the same place because, it's human nature to like. I'm sure 90% of groups didn't effectively make use of the first week, which is fine. I'm not judging you. That's my life as well. It's just the life of assignments is always quite funny. So a couple of things. I think firstly, there's going to be a whole bunch of groups that didn't do everything today, and they've submitted it feeling like they didn't get everything perfect. That's okay. There will be a large number of groups in that exact position. There will be groups that forgot to submit it. There will be groups that submitted something that doesn't work at all. Don't get too caught up in your head about it because there's a lot going on for lots of different groups. So, I'm a bit sick, so I'm sorry about that. If I talk slower, which will please some of you and annoy some of you. Just reading the chat. One thing I wanted to quickly address, really quick. Someone said, group projects, it's just like the real world where your co-workers get paid to exist. I love this comment because it's kind of half true and it's kind of half not true. Like, it's an interesting thing to explore, which is like, and I see this all the time, which is that question of like, some people say literally, like your tutors might say this literally, for instance, it's like, this is exactly what happens in the real world. And then you get the standard response, which is like, well, in the real world, everyone's at work paid to do their work, so people don't really disappear. And I think I don't want to get into this too much, but I think a really important aspect of this for everyone to take away is not that, because I think what gets lost sometimes is it's not that the struggles that are encountered when you do a university assignment are identical to the struggles you encounter in like the workplace, right? Like, that's not true. What's true though is that you encounter struggles and that you have to deal with them. That's kind of like at the core of it. So like, for example, just as an example, it's like, in a 1531 project, some of you deal with, like a small number of you deal with people who like completely disappear, right? And in the workplace, you don't really have people that just don't turn up for work for a few days. Usually that happens sometimes, but usually you find out it's because like their cat died or something later. Not just because they're lazy or disenchanted, right? Because they don't want to lose their job. But on the flip side, you do find people at work, for instance, who will ask you to do something, go do it themselves, and waste 2 days of your life. So, you do that. You'll find people who you'll do stuff and they'll completely change what you do. You'll find people who expected you to do something never told you about. Like, it kind of goes on for a while. And I think like one thing that's really interesting is like, working with people this is a lesson I kind of had to learn. It's like, in a general sense, dealing with people that make you want to pull your hair out is like a fact of life that you never escape. And it's all just a question of like, how well can you learn how to operate in that environment, like emotionally and practically, for your own sanity and like accomplishment. And you know, there's different problems, and like, of course, yeah, like I would imagine uni's a little bit worse than the workplace, but it's like, to be honest with you, the most miserable I've ever been made by people I've worked with are always the people that are like way, way, way too like aggressive or commanding or condescending or territorial than people who don't do their stuff. You know what I mean? And I'm not saying that's for everyone, but it's like, it's a very complex world. So I guess my point is, I wouldn't ever want a student to sit in 1531 and be like, well, I'm preparing myself for the workplace, where like someone just doesn't reply and for a week and stuff like that. Literally that exact thing, but it's like you wanting to pull your hair out and have to figure out, how do I navigate through this thing I'm not in total control of? That in a broad sense is actually, like, tragically, I don't think it's a great thing, but it's tragically a very common experience, even at the best of times. So anyway, I just wanted to talk about that. Girichan says, I need some life tips. A couple of weeks ago when I actually watched lectures, you said you liked working. I said I liked working. That's a curious statement. I'm not really sure the context of that statement. I guess just to tie it into like what I don't know. I mean, sometimes sometimes I've tried my hardest to take some satisfaction out of working with people that I want to like pick them up and throw them out a window, because again, I remind myself that like those types of people are not something I'll escape, right? It's something that like I either have to like, I either accept that I can't deal with it and go sit in a basement somewhere for the rest of my life, or I accept that I have to learn to deal with it and I go deal with it, and I take that as my like motivation. I'm like, well, I mean, if you deal with it, you're kind of going to have a bit of a happier professional life. And again, just to comment on all of this, like, lastly is, every time I say, so I want to throw someone out the window, that is not like, again, the common mistake I think people make is like, most of the time when something goes wrong again, when I say most, I mean like maybe 60% of the time for like group work, it's just because like people aren't in sync and they haven't learned how to work together yet, right? Like sometimes there are genuine a-holes and genuine pains in the butts, but like a lot of the time, you know, even though you want to pull your hair out, you kind of have to take a step back and be like, you know, let's assume for a second that I'm not unfallible here, and that, you know, there's work that can be done on most parts, everyone's part. But again, I know some of you have had the raw end of the stick, some being a very, very important word, because it's definitely not a majority. Because I mean, I get emails about this stuff all the time. Great, let's move on. We've been talking for 10 minutes, I think. 9 minutes and 40 seconds. Yeah, the memes were funny. I'm glad GitLab went back up. I didn't really put it back up. Like, I don't have any control of GitLab. I was just praying. I was like, please come back up within a reasonable time period so that I don't have to do anything about this. And I think it was down for 3 hours, which it's like okay, right? Like, I mean, if it went down at like 1 p.m. and came back up at like 8 p.m., then that's probably falling into like extension territory. But it's really tricky because we have to have your iteration 3 due before your labs in week 10, where you get marked. So we can't actually push the iteration 3 due date back anymore. Like, we've never had it this late in the term before. And they got pushed back a day because of Easter. So it's like, if we gave an extension, I don't think it would help, you know what I mean? Like, I think you just end up having less time to do iteration 3, which we're going to talk about at the end. So what is today? Well, again, 8.1, which is this bonus lecture this afternoon, that was originally intended to be done yesterday, but I have been very sick this weekend, so I decided to do that this afternoon. So today we're focusing on 8.2 and 8.3. Now, 8.2 is about deployment. How do we get our applications out in the cloud? It's a kind of exciting topic. And 8.3 is iteration 3. What's the spec say? And a couple of tips about it. We might have to pre-record some parts of that later, but we'll see how we go. Iteration 3 is being released this afternoon sometime. And I know you're all like, oh my god, no. But again, just because we're releasing it doesn't mean you have to work on it today. You know, I would expect most people would say, I'm not looking at 1.5. My genuine advice is possibly for those of you who feel burnt out from the weekend, take a break till your tute this week, unless your tute's on Friday or maybe Thursday night, then maybe look at it before. But it's like if you have a tute on Wednesday, for instance, or Thursday morning, just take a break, meet up with your group in the project check-in or after, and just be like, you know, let's get it let's get it done. Okay, so SDLC deployment. Bit of a waffly topic, but a super interesting. What the hell? Okay, I can't link things. I'll fix that up after the lecture. That's quite funny. I reckon I got the slides right though. Yeah, I got the slides right. The PDFs are fine. It's just my silly slides that aren't fine. Okay. Yeah, today. I mean, if you have your tute today, you can obviously like go to your tute and take a break after. It's funny. Cool. Okay. What is this topic about? Deployment. So if you remember back to the software engineering lifecycle, we talked about, you know, requirements, design, development, testing, deployment, and maintenance, right? So we're kind of getting to around the end of the circle at this point. And deployment's a topic that's tied to continuous integration. We already talked about continuous integration back in week 4 or 5. And continuous integration was the idea of automating the integration of code from multiple people into a single project. And again, you're familiar with that as pipelines. And you're all probably quite across that because it's been a big part of your last week, right? Trying to merge changes in that automatically are like linted and coveraged and tested and all that kind of stuff. But all that arguably falls into testing in a way. You could say it's like between testing and deployment. I don't really have a clear definition on it, but you know, this kind of helps you get to deployment, right? Because typically what happens in a software project is that you write code, right? You write some tests for your code, and then every time you push new code to, say, GitLab, one of two things happens. The first one is you have a continuous integration process run, which is your pipelines, and then after that, you typically have a deployment step. And then a deployment step is where you do something that makes your software available for use. Now, I know that sounds like a really waffly phrase, right? Like, what does my software available for use mean? But again, it's like if you think about what a normal normal life of writing software is, right? Like, you write Python and you can run it on your computer. There's no way that you could just as of right now, you know, you can't just build your UNSW Dreams app and just put it out on Reddit for everyone to use or play with, right? It's not available for use in a general sense. So deployment is the activity of making it available for use. And that's what we're talking about today. One of the most basic examples of making something available for use, which I'll show you, is if you go to VLab and you open up a terminal and you go from your home directory, right? My home directory, H Smith, yours will be a Z number, right? It'll say like, you know, import ravel1/Z555. And I go into a folder called public HTML. Everything inside this folder on the CSE machine, and I know a handful of students are aware of this, this is all public on the internet. So if I was to create a file here called COMP1531.txt, and inside of that, I would put I love COMP153, can't spell, COMP153121T1, perfect students forever, and then I save that file, and then I do a really important step, which is beyond the scope of the course, where I actually make that file like able to be like, give it the right permissions to be read by strangers, basically. This is how you change permissions on a Linux machine. And then I go back to my browser and I type in cse.unsw, and after that I type in hsmith, which is, I might do my Z number because it's more relatable, and I open up a page here Slash, what was it? Comp15, oopsie. What was it? Z3? Maybe this will work. Let's see if it works. Comp1531.txt. Maybe it wants my, let's try this. Oh, yep. Or maybe I need a CGI. There's some combination of things that I don't remember off the top of my head. Forbidden. Okay. Well, we nearly got there with this one. I'll have a look at something that's less forbidden, like this file here, animals.json, that I put here before. Oh, I don't have permission to access that either. That's not good. Well, I guess today I've made a bungle of this one. What are the permissions in this folder? Should be fine. I'm just doing some random things. Okay, there we go. I forgot some random web thing. So now there's this file, and I literally just send this to you in the chat, right? Like I send this to you in the YouTube chat. It's like you can open this. It's on the internet. This is CSE servers. You click on this URL, it goes to your ISP. Your ISP talks to an ISP associated with UNSW, which talks to the K17 building, which pulls out that information and ends up back on your computer. So if you imagine that this text file is software, then the act of me putting it here publicly is the act of making it available for use. So in the simplest sense, like all we're really doing with deployment is this exact same thing, but we're doing it at a very different scale, right? We're doing it in a much more automated way for much more complex software. So how has deployment kind of changed over the years? And this one's pretty important. So in the past, pretty much like pre-internet being the main thing, deployment wasn't really a concept because software wasn't on the cloud, right? A big part of what makes deployment a topic is that you can kind of release software digitally, right, as opposed to physically. And a big part of this is because software used to be, you know, floppy disk CDs and all of that kind of stuff. Probably the biggest things that have changed in the last 10 years are the prevalence of like web-based applications, which are most of the tools you use these days, right? Like GitLab, YouTube, everything else. So like instead of like 10 years ago, you having to get a CD in the mail for like the YouTube 2.0 update that you would install on your computer, now it's just like you log into YouTube every day and it's like the new version of YouTube from yesterday. And another big thing that's made deployment, as in pushing software out regularly, a lot easier is the fact that we have a massive improvement to internet connectivity, speed, bandwidth, and everything else, right? Like you can casually download a 700 megabyte iOS update, whereas like 10, 15 years ago, that was crazy. You know, that would take days to kind of download. So these changes have made pushing software to users much more plausible. And this whole idea has been that we no longer see software as this kind of asset that we sell, but rather that it's this kind of digital abstract service that we provide to people, and we're just like kind of constantly updating it, right? Like Netflix is one of those examples. Like nowadays, like think about how you don't buy software anymore. And I know a lot of you are young. I think like I'm 27, and most of you are going to be like 19 probably, maybe 20. But like you know what it's like. Used to buy stuff. Like you buy something outright, like a $200 something for some software. Whereas like nowadays everything's a license, right? Like you $10 a month for Netflix, $20 a month for this, $3 a month for Spotify, and this is how you're interacting with modern applications, and these applications are just getting updates all the time, right? They're getting new code is pushed every day, typically deployed every day for a lot of companies. And this is pretty much just what I've described here. There's a great article for the potentially one student in this course who thinks this is interesting. There's basically an article which is really interesting about how Windows made a massive transition between Windows 7 and Windows 10, where like it's crazy, like back to Windows 8 to Windows 10, because it's weird to think about. I think Windows 7 you couldn't even download, right? Like Windows 7 was on a disk, and then two versions later to Windows 10, they'd completely adopted the mobile, like the phone approach, right? Which is like you get an operating system on your phone. You never have to install, like put a disk in. It's like the idea is you're just constantly deploying new changes all the time, as frequently as you can. I mean, do you guys remember when you used to have to update your operating system? Because like with operating systems, you used to have to do massive updates on disk. And then you do little updates, like, I don't know, every week or month or something, to be like, it's time to update Windows or something. And like nowadays, you probably don't even notice it, but your operating system's just updating all the freaking time. And the big updates you see on your phone, right? Like your phone's like, oh, time to do a massive update this month. But anyway, it's a whole different world now. So if we move from like physical disk to predominantly web, which is where most things are hosted, things have kind of changed in the sense that, again, years ago, your email client might have been Outlook or Apple Mail or something, and some of you would still use that now, of course, that is actually running on your computer. So you'd actually install a massive application on your computer. And a thing that's made deployment so possible, is in like regular deployment, continuous deployment is what we call it, is because all these things are hosted up on the web now. So rather than you have to like reinstall all these things on the operating system, you're just changing like your Dreams backend, right? Which is just this abstract thing up here that people are interacting with. So you're kind of in control of it. So like less and less is actually on your computer now, and more is kind of in this veil of the internet. And there are massive providers that help make this happen, right? And this is the whole cloud services boom that you've seen. That actually like power so many things now. Like, Amazon Web Services powers Netflix. Google App Engine, Google have huge clouds. Microsoft has Azure. Heroku is another biggish player, I think, I wouldn't know how to articulate the community. But there's tons and tons of services out there that help you actually host things so that you can, run your software and deploy to it regularly. These like cloud-based providers. And this is typically what like we've talked a lot about like the infrastructure around it, but it's like, this is typically what a modern deployment pipeline looks like. And I love this diagram. I don't know where it's from. I think it might even be from GitLab's website. It kind of looks a little GitLab-y. It's from one of the big Git companies. And it just kind of shows you, you have your code, you have more code you add, which you push into master. Then you typically end up in your continuous integration pipeline, which is like build, if it's like a C programming language. You're testing, you're linting, all of that kind of stuff. And when that's all good and everyone's happy, you move into your continuous deployment, which is like all right, let's make this available for use now. Let's share this with people. And there's a whole bunch of variety that can happen in that continuous deployment section here, right? But it's the point of, you're really happy with things at the end of the CI pipeline, and now it's time to make it available for use. So when we make it available for use, this is again called continuous delivery. Well, not again, it's like, this is what we call continuous delivery. I've been using the term deployment, which generally just describes the concept of making it available to use. In a lot of ways, you could argue that what I did by putting this up in my CSE account here is a form of deployment, because I've made it available for use, but it's not an automated, scalable way to do that. So what CD actually stands for in a diagram like this is continuous delivery, which is a form of deployment. And continuous delivery is essentially it describes something that allows us to accept code changes to be deployed to customers quickly and sustainably, and it uses the automation of a release process such that releases can be done at the push of a button, right? So in one push, I can like release my software out to my users. That's at the highest level. Typically, when you work with continuous delivery environments, you're working with at least a production environment, which is what people are actually using, which we often call prod. And then sometimes you'll have another, typically 1 to 2 environments, which are like your kind of like what you call your staging areas or tiers or something like this. So it's like, because like you could imagine it, if you have a UNSW Dreams application and you're like, yep, we've got some new code, you don't often want to make that available to like, all the users at the same time, right? Sometimes you want to make that available to just some of the users. Or put that on a closed environment where only people in COMP1531 or maybe only people in your team can see it. I'm just looking at what's on the next couple of slides. Yeah, okay. Sorry, I'm just jumping around. Yep. So typically, dev, like if you have a dev deployment, that's usually referring to like something that's very internal. And you're releasing to it often, and it's going to break sometimes. So like at work, for me, for instance, dev is the deployment that always has the latest master every single time. So at any given time, we have an environment that's actually like available privately, that's always the latest changes of master. Then sometimes companies will have a test environment, which is basically like a ready to go into production environment that they'll often give to people they're building it for, like actual, customers or clients. If you would, in the case of the UNSW Dreams app, a test environment might be something you give to like UNSW IT or essentially the person you're working for to like be like, are you happy with these changes? And then the production environment is the one people are actually using. It's the one people are actually working with the whole time. We'll come back to this a little bit more when we talk about flighting. So in terms of continuous delivery, which is again is the process of automating, the pushes to like dev or test or production being the main one, different companies, different organizations will have different ways of going about this. Some of them will have a daily or weekly push. Some of them will have like every second day. Some of them will do it even less frequently depending on the type of software. And the idea with this stuff is you always want to get them in some kind of cadence. So you're, doing this regularly, because the more change, like you all know this from writing stuff with Git, right? The bigger your Git commit is, the more likely it is to break, right? Like the more code you've written that's going to change, the more likely it is to fall on its ass and break. Yes. And then typically before you actually release this code, there is usually some kind of sign-off process. Sometimes it's as simple as, maybe your boss making the decision. Maybe like there's some quality assurance engineers. Maybe your tests are so solid that you trust your tests completely. Maybe you have to like have it looked at by a couple of people. That's totally up to the team and the decisions they make. And when we do this release, we often refer to it as shipping. And I think it's a big thing in Atlassian. I think I saw them starting to say it publicly first with some of their like ship it weeks and things like this. It's like shipping it being like the kind of classical term where, if you made some new stuff, like imagine some CDs of software and you were to release it, you'd be shipping it out, right? Like you'd put it in boxes and you'd put it on boats and it'd go out to the world. So, can we ship something means like, can we release it? Can we deploy it? Can we make it available for use? This is just another diagram thrown in there to kind of, help understand that continuous integration is about making sure that your code is meeting a standard and well integrated stably, and continuous delivery is about making sure that you're actually able to release / deploy your stuff for people to operate effectively. And there's some stuff you can read about this. Just an Atlassian and GitLab blog, though, these lecture slides should go into sufficient depth for anything you might be assessed or asked on in this course, so don't feel obliged. Now, the last part of, one of the last parts is this idea of flighting. Now, I have to admit, I feel like this slide here is probably slightly out of place and should probably have been on this bit here, so I apologize for that, but basically, when we talk about continuous delivery, we could just be saying, oh, that's just about automating the production, automating the availability of use to production. Whereas in reality, there's many stages. We've just talked about this before, so we've gone through it about like dev, test, and prod. I think I've dropped a slide in the wrong spot, I'm sorry. But I just want to articulate that there's no like hardcore. There has to be 3 environments or 2 or 1 or anything like that. It's just the idea that there are multiple layers sometimes, from production to production, and like God knows how many. And the process we have of like moving these out from layer to layer, from, you know, like the most basic, like in this case dev, all the way to production, is what we call flighting. And we call it flighting because like flighting is in like, you know, like where, I mean, how would you define, I don't know what the Google definition of flighting is. Deliver with well-judged trajectory and pace. That's a beautiful definition. Provide with feathers or veins. Okay. So yeah, like flighting is this idea of just like I don't know. When I think of flighting, I think about a bird flying, right? Like it's, you're trying to go from A to B. Like fly away, go do stuff. I'm gonna stop talking about flighting. And this is a diagram that I stole from the Windows Insider program. I googled it and found it from the Windows Insider program, because this is like the people, when I was interning at Microsoft, the work I was doing was in the same grader group as the people doing this, and I thought it was interesting conceptually, so I remembered it. And the whole idea was just that when, and this might be dated now a little bit, but with Microsoft, for instance, when they do like a daily build of Windows, right? Like Windows is an operating system. It's just like software. There's a repository for it, probably, and it builds and you can run it. And what they actually have is a series of rings or flights, right? Like dev, test, prod, that they release to in succession as they get happier and happier with things. So Canary, for instance, here is the daily build. So every single day at Microsoft, their servers will do a build of Windows 10. I guess it's just Windows now. And that's called Canary. And certain people, particularly Windows developers, will use Canary. Maybe they'll have a second laptop with this on it so that every day they're getting these software updates. So you know how you get like a Windows update every week or month or something like that, right? They're getting these updates like every day. And it's the new build and the new stuff. And crazy things happen. You know, the computer crashes, the screen goes blue, and that's like how they catch things internally quicker before they release it to the next stage. So if they're like, well, this isn't fundamentally broken, then, you know, typically it finds its way out. Now, don't take what I'm saying literally, because I'm not familiar with the specifics of these processes, but it's more like the general concept. So you can see here, like, once it makes it past a couple of internal things, and you can see the blue ones are internal, there's a couple of public ones, and you can actually go subscribe to these. So Windows Insider's Fast, for example, you can actually go to like the Microsoft site and basically say, I want to be part of that. And you can get new features on Windows even quicker than other people, but they're more likely to break. So I had some friends, for instance, that I know I know a lot of you have been using like Windows subsystem for Linux, and when they released version 2.0 of it, I had some friends, for instance, that tried to get on the Windows Insiders list because they wanted the feature earlier, but some weird things started to happen to their computer. Once they release it to Insiders Fast, they then release it to the whole company. So if you're a Microsoft employee, you're working with that. And then it goes on, and then they release it to like, you know, Windows Insider Slow, which is like people who kind of don't want everything to be super broken. And then if they get a sense that things are fine, they move on to like the next one, right? So this is what we call flighting, moving through these layers. Now, the rest of this lecture is just some small couple of notes. First one is there's this other phrase called continuous deployment. And you might be thinking, what's the difference between continuous deployment and continuous delivery? Here's a great diagram which looks a little Atlassian-like, I think. I can't remember. And it's basically continuous delivery, except the decision to release is totally automated. I say here that the only thing stopping them is a failed test. That's true, but also it's like you'll have a couple of things here. Typically, the release will be only happens if it passes all the pipelines, right? But then also sometimes it's time-based. Sometimes it only happens like at 10 a.m. every day or at 12 p.m. every week or something like this. So it's not always just like releasing all the hell time, right? Like, because if you make like 6 big changes to master in a day, you don't necessarily want to like release your software to a million users 6 times a day, right? Maybe you'll do it every week or every day or something like that. But the point is, continuous deployment is the act of automatically making the decision to release, whereas continuous delivery is automating the whole process except the specific decision to say go, click the big red button. And there's some more reading on that. It's definitely from Atlassian. It's funny how the diagrams kind of look Atlassian-like. Style is funny. Oh, I put that slide in the wrong spot. Okay. No, we'll do this one now. So we'll probably go maybe around, we'll have a break probably slightly after 12. Just quickly, Praf said, do mobile phones hold auto hidden updates? I don't know about phones. I know a lot of apps these days will update quietly behind the scenes, definitely. I don't know about the phone operating system itself. The fact that like whenever I get prompted for a phone update on Android, it's a big file. Which makes me wonder if like they don't do updates super often for phones. But I don't know. I don't know a lot about phone architecture. Okay. As part of iteration 3, we're going to ask you to deploy your code. Now, thankfully, that is actually possibly one of the easier parts of iteration 3. So it's not actually a scary thing, and we've actually made it like a little bit dumb in the sense that like we're not asking you to do like a full proper thing. We're asking you to just do something that's like quite prescriptive so that it's like, oh, this is fun, and you can see it. And what I'm going to do quickly is take you through how to do that in the lecture so that you have a little bit of demonstration behind it, so we can show you how to actually deploy your code. And the instructions are inside of your iteration 3, which is not yet released, but it will be released. How do I never know how to work this. Oh, I can just go to the branch. Yeah, so we're going to release your iteration 3 today. And you know, it's the same thing. We'll talk about this later, but there's a particular point of iteration 3 where we tell you how to deploy your code, right? Like how to actually put it up on the internet. And when we say deploy your code, we don't mean the whole application. That's a little bit more complicated, like including the front end. We actually just mean your back end. And you might be thinking, oh, that sucks, I want to have the whole thing up. It's like, okay, if you're curious, you can go do it for bonus marks. But the back end being up online is actually pretty cool, because if your back end's online, then in theory, if all of your team members run a front end locally, and all those front ends are connected to the same back end on the internet, you can actually use your Dreams app to communicate like literally anywhere. Like you don't have to be on the same route or anything. You can just communicate anywhere, anytime. So that's a cool thing. Yeah, actual bonus marks. We'll talk about iteration 3 after the break. I just want to get through the deployment stuff. But it's a good question. So you'll be deploying your whole iteration 3. For the sake of this lecture, we're going to be deploying a really simple Flask app because it's quicker and we don't want to, confuse you with stuff. And this Flask app is sitting inside lecture. Don't like that. Ugh. I probably shouldn't have done that. I think I'll regret that in T3, but you're all that matters to me right now. Okay, so inside of week 8, in the lectures folder, I have another folder called deploy. And inside of that, I have a couple of key things. I have a requirements.txt file, very simple, just has Flask in it. And inside the source folder, I have one file, which is server.py, right? And all the server.py has is it's a simple Flask server. It has a / route for hello world, and it has a /test route for testing world. So it just has 2 routes. And then it runs on port 8080. Right, pretty straightforward. I think it might have to run on port 8080, by the way. By the way, we've never actually asked students to deploy stuff before, so this is totally new. So there will be the odd thing that we uncover that we realize you don't. We'll figure that out. But I spent hours, literally hours yesterday writing these instructions and going through it myself. So it's very prescriptive. It's very unlikely that we should have major issues. So this is a very simple Flask server. So if you imagine for a second that you are, this is your project folder. You've got your GitLab YAML file, you've got your source folder, your test folder, your requirements.txt, your pylint. It's all in this folder. There is a magical file that we're giving you called deploy.sh. This is a file that you aren't expected to understand because we don't teach you shell or bash scripting in this course. But you can use it. We've written it for you so that you don't have to write it. And basically, this is the file that will help you actually deploy your stuff. Most of what you're doing with the deployment is actually clicking around a website, and we'll do that together now. So, step one here. I'll open this in another tab so that we can... oh my god. Oh, what's wrong with this website? Okay. So the application that we've chosen to help you deploy is called Always Data. It's definitely not the best tool on the internet, but it's free, it's non-abstract hosting, and it's free. It's fine. It like does the job for 153, and I don't think I'd probably use this much for my own stuff, but it's great. It's cute. I mean, it's not terrible. I don't know what I'm talking about. So first thing I'm going to do is I'm going to navigate to that website and sign up with a new account. 1 per team is fine. Great. I'm going to enter my email address, hayden.smith@unsw.edu.au. Use a password you're happy both sharing with your team members and being made public on the internet in the worst case. Well, I mean, I'm not going to share that one with you because, you know, you might make me sad somehow. But let's just put password. The password I'm writing is... Hayden is great. That's not really it. My name is Hayden, sure. My phone number, I don't need to enter that, so you don't need to enter that. The address, let's put in something random. 8 Hillsong Street in the CBD of Sydney. And I came from Snow Camp 2020. Yep. So the account name's pretty important. Here I'm going to put an actual group. Now, just for... I know there's no groups on Monday, so I'll say I'm in Monday 09B Echo. Right, and that's what it says here. You know, set your account name as 1531 group name. I don't think it matters if it's capitals or not. And then there's all the payment stuff, which you don't have to worry about. I mean, generally, if you don't enter a credit card, everything's always fine. You tick some boxes... You click sign up, and then it should hopefully sign me up. Oh, my password's too weak. Okay. Let's try that one. Sign up. Great. Sure. I don't know. I don't do that normally. Okay, go to the administration interface. They're probably going to want me to sign in. Oh, okay. Log in. Great, okay, now I've logged in. After logging in the sidebar, click on the web sites in the sidebar. Okay, web sites. I'm taking you through this so that whenever people post on the forum, I can point you to this lecture. So if you haven't seen this lecture and you post on the forum, welcome. Number 3, delete the default site. Okay, there's a default site here. Okay, I'm going to click delete. It's gone. Yeah, I want to delete it. And then click on the install an application button. Yep. I'll click on this button, and then I'm going to choose Flask here, and I want to install Flask. Choose. Great. On the details page, choose a name, COMP1531 deployed. Set the address to be the one stated immediately above input as currently unused. So you see here in addresses, they actually say that there's a URL that they have for me that's currently unused. So I'm going to select that one and paste that in here. You'll have the same if you follow these instructions. If you don't, you haven't followed the instructions. Yep. And for installation, set it to be www/cs1531 deploy. Great. Accept the conditions. Click submit. Perfect. On the website pages, yep. Go to edit. So I'm going to go to edit here. Scroll down and change application path to that. Okay, so instead of this one, I write source server.py/app. Great. And change Python version to 3.9.2, which it already is. Perfect. Submit. And then we're on to step 7. We go to remote access. Navigate to the remote access tab and select SSH. Click on the edit button for the one entry that is there. Okay, it says one entry that's here. I click on edit. Enter another password. Great. One that you'll be comfortable sharing if it became public in the worst case. The reason I say this is not because we have your passwords or we'll share it. It's just like there's always the chance that we figure out how to like allow you to automatically do this stuff more, but it involves you putting your password on GitLab in source code, which is a little bit insecure, but it's fine. It's not like something scary. It's just like don't put in your personal password. And then tick the enable password login button. Perfect. Great. I click submit. Submit. Sorry, my face is in the way. Yep. Opened. Okay, so we've done all of that now. Now that's all the hard work done. Now step 9. Open deploy.sh in your cloned repository. Now, for iteration 3, we will be adding this file to your repo, right? So if you're like, where is this file? It will be added to your repo just like we added the PyLint-RC file and stuff like that, right? So it'll get added. So they say open our deploy.sh file. Okay, great, sure. You will need to replace the to do with the following. Okay, I can see that there's two to-dos here. First one, username. The username I signed up with. What username did I sign up with? I believe it was Monday09B Echo. If someone remembers that differently, let me know. Great, perfect. And then the SSH host is the name of the host at the top of the SSH page. Ooh, okay, so that was the page I was just on here. Oh, there it is, right there. So I'm going to copy that SSH host name. Perfect. Okay, I've put those in. I've saved that file. Yep, I've shown some changes there. Okay, that's all the setup you do. Now, I might have missed a step. We'll see if I missed a step in a sec. But that's all you have to do. You're all set up. You do that once for your project. Every time you want to deploy now, what you do, and this is assuming that you have the latest master on your machine, right? This doesn't deploy from GitLab. This deploys from your local computer. Is you type into your terminal bash deploy.sh. Now, this probably might not work on native Mac or native Windows, so generally it's probably going to work on Linux terminals. See if it works on Mac. We'll see how it goes. If for some reason it doesn't work on your computer, it gives you some errors, just log into VLab, clone your repo, do it there. I know some of you don't like VLab, but I mean, that's barely using VLab. So I'm going to get prompted with this thing first. I click yes. And then when I run this script, I'm going to get prompted for my SSH password twice. This is the second password that I set. So I enter it once. It's going to do some stuff. What it's actually doing here, oops. What it's actually doing here is it's pushing my files up to the cloud now. And then the second time I do it, oops, I think I typed it wrong. Now it's actually going to be installing the applications for me, and yep. So I do that. Done. Now the last step is once I've done this, go back to the website, go to websites, and then click on the restart button here. That's to restart the server. And then when I go to this address, it works. Oh my god, it worked. Oh. Sorry, I wasted a lot of time on that yesterday. So now, whenever you make changes and you have the latest master, it's really simple. You go here, you type in bash deploy.sh. This is like think of it like an automated way to do stuff. Normally you wouldn't have to type in a damn password. Don't choose long passwords like me, that was stupid. How many N's does banana have in it? I think I get it wrong. I'm having to type it in 3 times here because I think I'm typing my password in wrong. Okay, I click restart. And now I've deployed it a second time. Okay, if I go to /test, I have testing world. There's my Flask server. So if you do this and you actually would open up ARC or Postman or Insomnia or something and use this URL instead of localhost 5000 or 8000, you could actually interact with a real web server with your team members. And it should be persistent too, because you've implemented persistence. Okay, so that's deployment. That's a demonstration of how you can do it in the context of 1531. In the real world, we're in the real world. In a bigger world, you'd probably use some other tools, but that's a great free tool to have a lot of control over your system. Okay, last couple of things before we have a break, and then we get into iteration 3. First one is just a quick comment on this term called DevOps, which we've talked about before. We talked about this back in like week 1. I just want to mention it again because DevOps is basically this idea now that, again, your job is not just to be a software engineer or a test engineer or someone working in infrastructure, but rather someone who sometimes can understand all of these things together. So that's why we try and teach these things, because like there are a lot of DevOps roles out there for people who aren't just like good software engineers, but actually understand how to make these things public and stuff. Yeah, so, and the idea more and more now is that DevOps isn't a role per se. Like there are still people that are hired, but rather that critical people in the team need to understand DevOps. So, if you're in a team with someone, maybe a team lead or someone who works in cloud or an SRE or a product owner, will have some of these roles or capabilities. Point is, it's not good to be a software engineer in a vacuum not knowing how your software is released. It's just a good general skill to have. Last thing from this topic is the final part of the SDLC phase, maintenance. We don't talk about this much in the course because there's not a ton to talk about without a lot of good examples. But maintenance is the idea of, after you've deployed, after your code's out there into the world, using analytics, monitoring, research tools to ensure that the platform is used and remains healthy and that it achieves its purpose as well, right? Because this can be taken literally, like, is the server functioning and not erroring? Or it could be taken on the other part, which is like, let's monitor our users and learn something from them. So I've said here that monitoring often has 2 purposes. The first one being preserving the user experience that you intended. For instance, at my private work, we've noticed that about 4% of our HTTP requests are returning 500 errors today. We're not sure why, so we're going to have to go look into that. And then the second part is like enhancing user experience, which is like using tools to understand user interaction. So maybe you're monitoring like what buttons they click or how long they spend on the site, or like, where they leave the page or something like this, so that you can learn, so that you can take all your knowledge and take it back to the start of the software development lifecycle and establish new requirements to make your software even better now that it's been released, right? And we're always in this iterative learning process. I kind of touched on this already. Great, okay, well, 11:02, how perfect. So let's take a 5-minute break, 5, 6, 7 minutes, I don't know, something like that. And yeah, that's pretty much it on deployment. So good luck with that part.